what are traits? To give you a very simple explanation, what traits look like is that it's an interface with public functions where we do not define what the implementation is, we just declare them. So any Clarity contract can implement these traits. And when we implement them in a contract, it means that you need to conform to it, meaning that the functions that have been declared, you need to write implementation for those functions. Now, so a simple definition is it's a set of function signatures that define a contract's public interface. You might have come across interfaces and inheritance in other languages. I am hoping that you're familiar with it, but I would like to know from the audience today, have you heard of composition and inheritance, or have you worked with that before? Okay, I see a bunch of answers here, worked with inheritance. So traits, clarity as a language. Okay, so I understand that you have the knowledge of what and how inheritance works, meaning that there's a piece of code in your parent class, and then you inherit the properties from the parent class, add new functionalities to it, and then we can have multiple subclasses as well. This is more of a model in object-oriented programming, and traits are in that sense a little bit different from that. They follow the composition model, and let's talk a little bit about what is composition and how it is different from inheritance, and try to understand a little bit that why Clarity favors compositions and traits over inheritance. So mentioning this again, that Clarity does not allow inheritance and it follows composition. So inheritance, in a very simple way, is a relationship, meaning that whatever classes that you inherit, any subclass inheriting any parent class properties, is the parent is inheriting those properties. So that's why it's is a relationship. So if you take an example here, a car is a vehicle. You can have more vehicles, and every vehicle would have the same properties. And then a person is a mammal, there can be other mammals, and everyone would have the mammal properties. So thinking of composition is has a relationship. I do feel that initially with programming languages, it was not very common. It was very easy and easy to understand inheritance, and that is what developers worked with. But as time has passed, the importance of composition has really shown. So the composition, which has a relationship, means that it has a certain properties that you need to conform to, but it doesn't mean that you're inheriting all the properties, or if it has been implemented for you already. So a car has an engine, it can have other properties as well. A person has a name, it can have other properties as well. So it is not completely dependent on what has already been defined or declared for it. So is there really a problem with inheritance? Maybe not, but one major reason probably for Clarity to decide that they need to follow composition and traits is basically that with inheritance, you very quickly get deep and wide, meaning that you may end up with a deep class hierarchy for some days. And there could be instances when you are updating your upper class and it could destroy the subclasses. So you have to do a lot of rework, and it could be both deep and wide. So composition, on the other hand, is basically quite loosely coupled. I do feel that you might have come across code conventions that your code should be more modularized, along with it should be loosely coupled. So with inheritance, your classes, your code becomes a little more tight, and composition, it allows you to more easily change your components without really breaking your code. So therefore, we go ahead with, using traits in composition, in Clarity. I hope that makes sense. If somebody has any questions on that or want to add more to this topic of composition versus inheritance, I highly encourage if you want to talk about, if you would like. No response in the chat. I'll take that as a no and move on further. Okay, so now we know what composition is, what inheritance cannot provide you. So let's directly dive into the technical specification of how to write a trait and how do we implement a trait. So you see an example here. We have defined trait. This is the function that we use to define a trait. You provide a trait name, anything that you would like to call your trait. Then you open a brace and then you list out the functions that you think that should be a part of your trait. And this trait could be useful and standardize the way different Clarity contracts can implement this. So for example, this is something that we will take a look in our next session. So for example, the NFTs and the fungible tokens. So developers have put a lot of thought on what your NFT token could look like. And therefore, they decided a standard for it. They provide you with a template, which is available on mainnet, which defines that NFT should have at least minimum of these few functions, which need to be implemented in your contract. So this is what traits are. Basically, you are defining what all functions you need to publicly make available and ask the developers, ask as per the use case, define how these functions would look like. So let's take a look at defining a trait. I'm moving on to my VS Code here. I hope everyone is able to see that.
Yep, I can see it.
All right. Now I'm in my practice folder, meaning that I am in my Clarity camp. I have a bunch of projects and I'm under practice project. You would find this in the GitHub repository as well. So you could take a glance there too. Let's say that you want to create a math utility, and this math utility would be using how to divide and how to multiply. And therefore, at some point, you decide that this divide and multiply could be used as a trait and then implemented in your contract. So how do you define a trait? So that would be define trait, and then you define a trait name, just because I already have these contracts created but not implemented. So I will only fill up the file here. So define trait, and I'm in my divider trait right now. I can call it divider. Now you see I am going to move this to next line to make it more clear. This is where my function is ending. This is where the list of functions have to be declared. And now I need to define a function. How does a function signature look like? It would be very similar to the function signature that we know, a function name, the parameter types, and what your response looks like. So these are public functions, meaning that there has to be a response type as well. So we have a divider trait. I could go with divide 1. I define what parameter types it takes. So this would be a list. Let's say that I'm providing 2 unsigned integers to it. So what my input would look like would be that only the types, unsigned integer and another unsigned integer. That means this function divide 1 is taking 2 unsigned integers. What does my type look like? I am dividing this. I'm dividing 2 unsigned integers, and it could simply be a success response of unsigned integer. And what does my error look like? Now, I am defining this response with both a success scenario and the error type. So error type could be anything that you want to go with. I will go with unsigned integer. That means whenever a response is returned in an error situation, I will return an unsigned integer. Because for me, it is more readable and easy to use as a developer. Now, I could have different sort of implementations for divide, and I could basically define all those here. So this is a very simple way of defining different function signatures and telling that what a trait looks like, and when we implement this trait, how does that work?